how Thomson tried to understand the atom and visualized it. He gave us the plum pudding model. But did it give an accurate picture of the atom? No, because it had so many flaws. But these flaws were taken care by Ernest Rutherford in his model of the atom proposed in 1911. Rutherford's model was a result of a very famous experiment which led him to devise a significant model of the atom. Would you like to see what he did? For that, let me take you back in time. This is Rutherford's lab and that's him working on the experiment. Let's check it out. Here, a thin sheet of gold is being bombarded by thousands of super fast moving particles. Pretty much like bullets being fired from a gun. These particles are positively charged and are called alpha particles. Let's see what happens now. Most of the alpha particles pass straight through the gold foil. Some alpha particles change their path slightly. Surprisingly, 1 out of every 12,000 alpha particles appear to rebound. Let us consider a situation to understand each observation. Imagine a swarm of flies rapidly flying towards this plate of food. Suddenly, a hungry lizard comes in their way. On spotting the lizard, the flies follow different paths. Now look at these flies. They follow this path and do not get affected by the lizard's presence. Can you guess why? Well, it's because they are far off from the lizard and have nothing to fear. So this means that just like this group of flies, the alpha particles too did not get affected and passed straight through the atom. Hence, the atom must have a lot of empty space. Now, why do these flies change their path? Obviously, they have to because they fear they could be eaten up by the lizard. Oh wait, this also means that these flies correspond to those alpha particles which get slightly deviated from their path. Their path changes slightly, but they pretty much travel across the atom. So, like the flies were trying to avoid being eaten up, in the same way, alpha particles also try to avoid something in the atom. What could it be? This thing is called the nucleus. The nucleus is a tiny and dense body that is present in the center of the atom. As it is tiny, it occupies very little space. But as it is dense, it is heavy. In fact, almost the entire mass of the atom resides in the nucleus. But why did the alpha particles avoid the nucleus? Can you guess? Well, it's because they were repelled by it. This means that the nucleus is positively charged like the alpha particles. This also leads us to understand why some alpha particles rebound by 180 degrees. They are repelled to the maximum extent when they head directly towards the nucleus. This is why they are deflected by 180 degrees. That's what happens to the flies too. Otherwise, they would end up directly into the lizard's mouth. Cool. So through this experiment, we got to know a lot about the atom. Now that we are clear on what Rutherford observed, let's see what he concluded from these observations. He said that, firstly, most of the space inside the atom is empty. Secondly, the nucleus occupies very little space in the atom. And finally, all the positive charge and mass of the atom is concentrated in the nucleus of the atom. So these are the conclusions and observations of Rutherford's model of the atom. But the study of this model is incomplete without a comparison with the Thomson's model. Let's see how they are different from one another. Thomson said that positive charges are spread throughout the atom. If Thomson's model was correct, all the alpha particles would have bounced back. Well, the positive charge in Thomson's model is spread out uniformly over the entire atom. Hence, this would repel the alpha particles no matter how they approach the atom. On the other hand, Rutherford predicted that the positive charge is concentrated only in a tiny space. So there are only some chances of deflections. Moreover, Thomson said that electrons are embedded somewhere in the positively charged sphere, but he was not sure of any specific region in the atom. On the other hand, Rutherford predicted that an atom consists of a positively charged nucleus with electrons revolving around it in circular orbits. This surely gave a more concrete idea about what an atom looks like. So clearly, Rutherford's atomic model is the winner here. Thus, on the basis of his experiments, observation, conclusions and comparison, Rutherford put forward the nuclear model which had the following features. Firstly, there is a positively charged center in an atom called the nucleus. Nearly all the mass of an atom is concentrated in the nucleus. Secondly, the size of the nucleus is very small as compared to the size of the atom. Finally, just like planets revolve around the sun, electrons revolve around the nucleus in circular orbits. This model was clearly better than Thomson's model. But alas, it was not the best as Rutherford's model had its own challenges. Let's take a look at them. According to James Maxwell, a renowned scientist of that time, if an electron revolved around a positively charged nucleus, it should gradually slow down. It would follow a spiral path and collide with the nucleus. But that doesn't happen, does it? If that were true, all matter in the universe would be destroyed. Moreover, if electrons revolve around the nucleus, how are they placed in their orbits? Does an orbit have 1 or 2 or 10 electrons? This was again something that puzzled Rutherford. Unfortunately, despite a convincing approach to understanding the atom, these unanswered questions became the shortcomings of Rutherford's model. Though Rutherford gave a clearer picture of the atom, he could still not eliminate these doubts that arose in the minds of the scientific community. But his contributions are nevertheless commendable. Let's see what happens next in the history of the atom in the next video. But for now, it's time to recap. Rutherford proposed his model of the atom in 1911 through his experiment. Rutherford's observations were most of the alpha particles passed straight through the gold foil. Some alpha particles changed their path slightly. 1 out of every 12,000 alpha particles appeared to rebound by 180 degrees. The conclusions from Rutherford's experiment were: most of the space inside the atom is empty. Nucleus of the atom occupies very little space. All the positive charge and mass of the atom is concentrated in the nucleus of the atom. The postulates of Rutherford's model are: there is a positively charged center in an atom called the nucleus. Nearly all the mass of an atom is concentrated in the nucleus. The size of the nucleus is very small as compared to the size of the atom. Just like planets revolve around the sun, electrons revolve around the nucleus in circular orbits. Limitations of his model were: Rutherford couldn't explain the stability of an atom. He couldn't explain the arrangement of electrons inside an atom. That's it for now, folks. I'll see you soon in the next video.